All right, let's get some learning in here. All right, so number one, we're going to look at the normal curve below, find mu plus sigma, and sigma. Okay, so let's talk about this. Mu, where do we find mu at in the normal curve? Middle. So the mu is the middle. So for me, my mu is going to be 51. Okay, mu plus sigma. Let's think about what that means. That means one standard deviation above. So what value is mu plus sigma? What I'm asking is that what's one standard deviation above the mean? What would that be? 53, right? The one standard deviation above the mean would be this. So it'd be 53. What is sigma? What is sigma? That's the standard deviation. So let's ask ourselves, how much am I going up by each time? About going up by 2, right? 51 plus 2 is 53 plus 2 plus 2. So my sigma is 2. Okay, so my mean is 51. Mu plus sigma would just be one standard deviation above, and then sigma is 2. This isn't too bad. You just got to get kind of past some of the verbiage and all that things, but it's not the worst. Okay. All right. Okay, making sure. I went too fast. All right. Look at the two normal curves in the figures below. So which one has a larger standard deviation? So now let's think about this. Standard deviation is a measure of spread. Or you could eyeball it. But which one has a larger standard deviation? Which one's more spread out? A or B? A, good. You could also look at the standard deviations. The standard deviation is how much you're going up or down by. This one's got a standard deviation of 2. That one's got 1 of 1. So A is larger. What's the mean of figure A? 10. It's just a center. What's the mean of figure B? Just a center, 4. Okay, I know this is kind of simple, but if we don't get these fundamentals down, it's kind of challenging. We all have to kind of start somewhere. And if we don't, we got to have this down before we kind of move to the next part. Okay, this is interesting. What percentage of the area of the curve lies to the left of mu? Mu is the mean. So let's go back. I can go back to the notes real quick. So let's go back to the notes. All right. Not very smooth here. And you might be able to do this kind of by thinking through it. But what percentage lies to the left of mu? Mu's in the middle. So you want to have any guesses what less arise to the, or what's to the left of mean? Well, how much do you think is to the left of mean? 50%. The mean divides it into 50-50. Now, if you want to add these percentages to prove it, you can. But the mean, when you have the mean in a normal distribution, 50% lies below, 50% lies above. So 50% is the left of it. Okay. What percentage of the data is under the curve lies between mu minus sigma and mu plus sigma? So mu minus sigma and mu plus sigma represents how many standard deviations below and above. Mu minus sigma is 1 below, mu plus sigma is 1 above. So what's the distance, or what's the percentage between 1 below to 1 above? 34 plus 34 would be 68. So between 1 below and 1 above is 68% of your data. Okay. What about from 3 below to 3 above? So mu minus 3 sigma and mu plus 3 sigma would be 3 below to 3 above. What percentage is between 3 below and 3 above? 99.7. Okay. So once again, fundamentals of the standard normal curve that you kind of need to know as you progress. Oh man, this next one's going to be kind of interesting. 4, it's not going to be too bad. 4, what about the percentage that lies to the right of mu, the right of the mean? What percentage is to the right of the mean? 50%. Remember that the mean splits it in half. 50% is below, 50% is above. This is for a normal distribution. What's the percentage between mu minus 2 sigma and mu plus 2 sigma? What's the difference between 2 standard deviations below and 2 standard deviations above? How much is in between there? 95%, right? Between 2 below and 2 above is 95%. So between 1 below and 1 above, 68. Between 2 below and 2 above is 95%. Between 3 below and 3 above is 99.7. To the right of mu plus 3 sigma, we actually did this in the notes. What's to the right of mu plus 3 sigma? 0.15%. Okay. So there you go. Okay. 5, they were nice and gave you this little normal curve here. I probably should sketch this out to be a halfway decent teacher. I'm going to do a white trash sketch of this. I should have this handy. So the mean on this one, the college women heights are normally distributed with a mean of 63 and a standard deviation of 6.4. All right, or 3.4. So 63 is my center, and I'm going to do 3 above, 3 below. Okay. Now, 3.4. So how do I go up? How do I go up? What do I do each time? Add the standard deviation. Yes. So add 3.4, add 3.4. Oops, sorry, I can't see what I'm looking for. So 66.4, 69.8, and 73.2. You can kind of visualize this. You don't have to write it down. I'm just writing it down because I'm teaching it, and I want you to be able to see what I'm doing. To go down, I said you could do this without writing it down. Minus 3.4, minus 3.4. So this would be 59.6, 56.2, 52.8. And if I want to fill this out, I could fill this out too, I guess. This is 34, 34. I won't put 13.5, 13.5, 2.35, 2.35, and then 0.15 is on the outsides. Okay, so you could fill that out if you want. You could follow the chart. Just do it in your head if you want. Okay, so this is a standard normal curve. This helps you get those percentages. What percentage of women are taller than 63 inches? Okay, we've already answered this question twice today, kind of. What percentage, where is 63 at? In the middle. So what percentage are taller than that? 50%, right? So if you're at the mean, what percent's above that 50? What's below that 50? Oh, goodness. What percent of women are shorter than 63 inches? What percentage is shorter than the mean? 50. So that you're at the mean, you're in the middle. So 50% are below, 50% are above. Now, between 59.6 and 66.4. So 59.6 is 1 standard deviation below. 66.4 is 1 standard deviation above. So how do I find the percentage between? What do I do? Just add these two. 34 plus 34 would be 68%. What about between 56.2 and 69.8? 56.2 is 2 below. 69.8, 69.8 is that's 2 above. Okay. So 2 below to 2 above. What's the distance between 2 below and 2 above? Do y'all remember? There's actually, you could add all these percentages up, or you can look here. What percentage lies between 2 standard deviations, 2 below and 2 above? 95%. Now I could add all these up here from here to here and get that, but it's 95%. 2.35. I'll just go and put 95. I'll prove it to you here while this is loading. So why is it 95? 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35. Oops. Oh, 99 points. Wait, I didn't mean to add this 2.35. I'm sorry. No, I add the 2.35 in there. It's just from here to here. I missed my chart's it's hard to read. So it's just that it's 95%. I'm not supposed to include the 2.35, so that's my fault. So I apologize for that. 95%. Okay. All right. Let's go to the next one. The incubation time for a breed of chicks is normally distributed with a mean of 21 and standard deviation of 3 days. Look at the figure below and answer the following questions. If 1,000 eggs are being incubated, how many chicks do we expect to hatch in the following time periods? We did not do one like this in the notes, but we can kind of apply. Let's first kind of apply. Let's kind of break this down here. So you could write this down if you want. You can do it in your head if you want. A mean of 21 and a standard deviation of 3. So I'm going to go 3 above. I'm going to go 3 standard deviations above, 3 below. So a standard deviation of 3 means I'm going to add 3 when I go up. And below, subtract 3. Okay, when I go down. And then I'll fill this out. I'm going to make it more readable than last time. I didn't do a good job last time. 34, 34, 13.5, 2.35, 0.15, 13.5, 2.35, and 0.15. Okay. So those are the percentages. So last time I didn't do it very well reading it, making it readable. 15 to 27 days. So let's first talk about this. Let's find the probability. What is the probability that you're between 15 and 27? Now let's look at this. 15 to 27, that 15 is how many standard deviations below the mean? 2, right? 27 is how many above? 2. So if you're from 2 below to 2 above, what percentage is that? What percentage is between 2 below and 2 above? 95%. I could add these up like 13.5 plus 34 plus 40. Yeah. So from 15 to 27 is 97% or 95%. Now, here's the thing though. That is not my answer because they're wanting to know how many chicks. So what I know is I know 95% of them are going to be between these two values, but I got to find the exact value of chicks. How do I find the exact value of them that's going to hatch in that time period? What do I need to do? You'll know what I need to do. I'm going to make this into a decimal. So 0.95 is decimal, or 95% is a decimal, is 0.95. And I'm going to multiply this by the number of eggs. So this will tell me how many chicks will hatch in that time period. So 950. So 950 will hatch in that time period, approximately. It's our guess. Okay. Between 18 and 24. So 18 is 1 below, 24 is 1 above. If you find that, that is 68% of the data. So how do I find out the number of chicks that will hatch? I'm going to take that to a decimal, multiply it by 1,000. That'd be 680. Just multiply it, just changes that. You can try that in your calculator if you need to. You've done this so many times today. 21 or fewer. Do y'all know what 21 or fewer, what percentage that would be? 21's at the mean. So what percentage is 21 or fewer? 50%, right? So half of them. So half of 1,000 would be 500. So 500. 12 to 30 days. So 12 to 30 days. So 12 to 30, that's 3 standard deviations. 12 to 30 is 3 standard deviations. 3 below. So it's 3 below. 30 is 3 above. So you could add all those up. It's going to be 99.7. 3 standard deviations is 99.7. So it'd be 12 to 30 would be 0.997 times 1,000. So it's 99.7%, but 0.997. So it'd be 997. Okay. All right. Let's look at 7. All right. Almost done. All right. 7, at a burnt Mesa Pueblo, archaeological studies have used the method of tree ring dating in an effort to determine the prehistoric people lived in the Pueblo. Wood from several excavations gave the mean of 1,251, a standard deviation of 31. Let me get somewhere I could write this. So the mean is 1,251, and the standard deviation is 31. The following distribution of dates was more or less mound-shaped and symmetric. What does that mean? Mound-shaped and symmetric means it's normal. Okay. Use the empirical rule to estimate the following. What is the empirical rule? The empirical rule is this right here. Okay, the empirical rule is this right here. The range of years centered about the mean, which is 68% of the data. So 68% of the data, the empirical rule for 68% is the mean. It's 1 standard deviation below to 1 standard deviation above. Whoops, sorry about that. So for 68%, it's 1 below. It's 1 standard deviation on each side of the mean. So it's 1 below to 1 above. So what does that mean? I'm going to take my mean, 1,251, subtract 31, 1,251, add 31, and get my answers here. Okay, so these will be my boundaries. So I subtract a standard deviation, and then I add a standard deviation. So for 68%, you're one below to one above. So 1,220, 1,282. Okay. So one below to one above. So 68% is one below to one above. Do y'all know what 95% is? 95% is within two standard deviations. So that's two below and two above. So 95% is two below to two above. So two below to two above. I'm going to go back to this here. So it'd be 1,251 minus 2 times 31. 1,251 plus 2 times 31. 251 minus 2 times 31 and plus. So 1,189 to 1,313. 1,189 to 1,313. Okay. The range of years were almost all is a reference to 99.7 because that's almost everything. That's within three standard deviations. So for the last one, you're going to do three standard deviations. So 97%, that's mu minus 3 sigma to mu plus 3 sigma. 1,251 minus 3 times 31. 1,251 plus 3 times 31. So you do three standard deviations on this one. 251 minus 3 times 31. Oh, I didn't mean to do plus first. It doesn't matter. So 1,158 to 1,344. So 1,158. 1,158 to 1,344. Okay. All right. Finally, number 8. So now the out of control stuff. So I'm going to do a Yellowstone Park Medical Services provide emergency care for park visitors. Such health care includes treatment for everything from indigestion to sunburn to more serious injuries. A recent issue of Yellowstone Today indicated the average number of visitors is 21.7. That were treated was 21.7, and a standard deviation of 4.2. It's mound-shaped and symmetric. That's implying that it's approximately a normal distribution. For a 10-day period, the following data shows the number of people treated. So we're going to see if it's in control or not. So let's look at the notes here. I'm going to make a control chart. Now, you could follow along with me if you want. There's ways to do this without making a control chart, but I'm going to make a control chart. So when I do a control chart, I'm going to start with the mean in the middle, which is 21.7. Okay, that's the mean. And I'm going to do two dashed segments above and two below. Above is the mean plus two standard deviations, and the mean plus 3 standard deviations. Okay, so the mean plus 2 standard deviations. I'll write that a little nicer. Sorry about that. The mean plus 2 standard deviations, the mean plus 3 standard deviations. Plus 2 standard deviations, the mean plus 3 standard deviations. Okay, below the mean minus 2 standard deviations, the mean minus 3 standard deviations. So I got to figure these values out. This would be 21.7 plus 2 times 4.2, 21.7. You could eyeball it by looking at the table. I'm going to do the control chart just to act like I'm a good teacher, but 4.2, 21.7 plus or minus 3 times 4.2. So 21.7 plus 2 times 4.2, 30.1 plus 3. Whoops, I didn't mean to do that. Plus 3, 34.3. So we're actually all going to have the same out of control because we all have the same mean and standard deviation. So we're all going to have the same parameters for this. It's just going to be a little different. Okay. 3. 13.3, 9.1. So we're all going to have the same boundaries here. Every one of us will have the same boundaries. It just comes down to plotting it. Okay, so we'll plot through this. I think these are going to probably be similar answers too, but so where does 26 belong? Well, 26 is above the mean, but not quite up to here yet. So 26 is in this area. 18 is below here. So it's below, but not too far below. 16 is a little below. 14 is a little below, or a little below, but still above that. 21 right there. 23 right there. 30 is almost above the first, or the 2 standard deviations above. 18 is back below. Okay, and then 17 is a little below. 24 is a little above. So I'll connect those. I'm kind of doing this quick, or I'm not taking up too much room because I don't want to go into the, I want to put the next problem on there. Okay, so there's my control chart there. We got to now go through the 3 out of control signals to see if it's in control or not. So we're going to go over that real quick. Out of control signal 1, is there any points that are more than 3 standard deviations away from the mean? So any points in these regions that are way out here? No, so number 1 passes. That signal is not there, so it's in control so far. Number 2, are there 9 consecutive points on one side of the center line? We've got 4 in a row. That's as much as it gets. We're good there. Do we have 2 out of 3 points that are more than 2 standard deviations away? Well, we have no values that are more than 2 standard deviations away, so we're good. So this one's in control. We call this in control because there's none of these out of control signals are present. These are the out of control signals right here. None of them are present, so it's in control. Okay, so that one's in control. Now let's look at the next one. All right, so I'm going to put those, I'm just going to continue this here because it's the same. We have 21, another 10-day period. We got 21, so that's right at the mean, a little below the mean. 14 is down here. 11's a little below. 22 and 23 is a little above. 27, a little further above. 33 and 37. 33's above here, but not above here. 37 is way up there. 34, yeah, that is above there. 38. What are we thinking here? Y'all got some preliminary thoughts on this? This is out of control. There you go. This is out of control. We got some, this is definitely out of control. Y'all are already all over that. Good job. The first one, do we have any points that fall beyond the 3 standard deviation level? Yes. So 1, I guess 1 kind of fails. So 1 is, one is the signal is present because it's out of control. 1's assigned out of control. Do we have 9 consecutive on one side of the line? No, not quite. So we're good there. 3, do we have at least 2 out of 3 that are beyond 2 standard deviations away in a row? Well, looks like we have 4 in a row that are beyond that. So that one's out of control. So 1 and 3 are, these 2 warning signals are present. I'm putting X's there because that kind of means they're out of control. I guess you could think of it backwards. So this one's out of control. Warning sign 1 and 3 are present. So if you're the park superintendent, do you think they need some more help? What would you say? Yes. And so basically, if you're analyzing this, you would say yes. If it's out of control on the bottom, that means they're not treating as many people. And then that might mean you need to maybe scale back on some of your help. Maybe you need to, let go of some people or reduce some hours. But if you're going above here, that means you probably need to hire more people.